Making calls to save Earth.
もしもしもしもしもし
Green forces, do you copy?
Hey, little popsicle, what you doing? Swinging around that fishing net.
Trying to catch some CO2. It's all over the place.
That's crazy talk.
Tisk tisk, little bear, you just don't understand. This fishing net here is made from a special material that catches CO2.
Woo woo! You mean direct air capture? Let me take a few swings.
I thought DAC was pretty much meaningless unless it's done on a larger scale.
That reminds me of a company that I heard about the other day. They're claiming to capture 100 million tons a year by 2030.
Interesting. I smell a business opportunity. Call them up.
Moshi moshi, Paul. Can you tell us about your DAC technology?
I think that it's clear from the IPCC documentation and climate scientists in general around the world that carbon removal is a really important tool to get us to net zero by 2050. One of the key advantages of direct air capture, particularly direct air capture at large scale, is that it's immediate and measurable carbon removal. So you can put a meter on the output of the system, and it will tell you how much carbon dioxide has been stored in durable geologic storage underground. And with that comes the benefit of having international standards that allow you to certify these sites and allow you to certify those carbon dioxide removals. So you have this large air processing system in the air contactor that takes large volumes of air, extracts the carbon dioxide into a liquid solvent, and then that liquid solvent then processed through two closed chemical loops. And so that carbon dioxide in liquid is then processed so that it precipitates out into calcium carbonate pellets in our pellet reactor. And then those pellets are taken and heated to release a pure CO2 stream that is then filtered and compressed and sent along to either the sequestration site or to a usage facility if you're creating e-fuels or some other utilization of that carbon dioxide. So the air contactor that's in behind me in the picture here has industrial heritage from cooling towers. Millions of cooling towers have been built around the world. The world knows how to make them inexpensively and in large volumes. There are some really strong reasons to want to build direct air capture in different places around the world. The technology, one of the great things about it is it can be built almost anywhere. And there are lots of interesting places to build DAC outside of North America. One of the key decisions that Carbon Engineering made right at the beginning of designing the system was to focus on being modular where it really matters and to be as energy efficient as possible. So Carbon Engineering's system is designed to be deployed at megaton scale. And we see that as the climate relevant. And what our founders really wanted to do was to create a system that would be easily scalable with existing supply chains. And so the secret and the really proprietary piece of the system is how we link those pieces of equipment together, but the equipment themselves they're tested elements from other industries. So Carbon Engineering is really a technology development company. And what we have done is really created a partnership with 1.5 to create a plant design that we can take and build anywhere in the world. And what we do is we work with a local territory partner who understands policies and the regulation, has access to land and utilities in a particular place. And generally, our territory partners have a lot of expertise either in oil and gas or in CO2 utilization or storage, and they bring that to the table as well. And by having a team that's skilled in the building and deploying of these systems, as well as the operation, you have significantly less operational risk and execution risk that comes into to building out these newer technologies. What the team has done at Carbon Engineering is we have designed the system to be a standard system that we will deploy at all the sites around the world. So by creating a standard design and being able to get manufacturers' production lines up and running and ready, a significant cost reduction coming from that. In the cost reduction frame, we really focus on 2 or 3 things. And the main one is the manufacturing piece. So being able to move from engineering a plant and constructing it in place to manufacturing it and putting it up on site in the future. That's what we expect, is that we'll have large scale manufacturing of each piece in the process. And those pieces will be shipped to the site and put together there. And that will greatly reduce the cost and reduce the time to build each of these elements. And then the second piece of the cost reduction discussion is around energy efficiency and air movement efficiency. So the more air that we can process faster through the system makes a big difference, because you reduce both the capital cost in terms of the number of air contactors you have to build. And then every time you take an air contactor out of the system, you also reduce the electrical load, so the renewable electricity load that you need for each of the systems. And that's an important part of the cost profile of any of these systems, is the amount of renewable electricity that's needed.
The cost aspect of DAC has always been its weak point. A solution that's scalable and affordable definitely seems attractive.
And it seems like a wise idea to tag up with a partner that has expertise in that field.
The great part about DAC is that it can be implemented almost anywhere, even on my glacier.
Maybe I can use that to replace the coconut tree on my head.
So you're going to cut down a perfectly healthy tree just for DAC? That's not very green.
Oops. Moshi moshi, moshi moshi moshi.